Hey, Algebra 1, we're getting ready for a module test over lines. So I gave a little homework assignment here that's going to cover some of the stuff we've been talking about. Talking a lot about graphing lines for sure, whether they're equations, or maybe we're solving those equations using substitution or elimination. Maybe we're talking about word problems. Maybe we're doing a slope, whether it's given 2 points, or maybe we're given an equation. We're trying to see what the rate of change is of that line. And let's just go from there. So on the front, let's start with x minus y equals 3, and I need to change the way that is written. So let's start by subtracting x to the other side. Negative y equals negative x plus 3. Let's divide by negative 1. So now we're going to divide by negative 1, and that will change your signs. So this is an equation. It has an equal sign. So there is no shading. It is only the line itself, starting at negative 3. Plug in 0. 0 minus 3 is negative 3. Plug in 1, you get negative 2. Plug in 2, you get negative 1. And so you can notice that rise 1, run 1 rate of change. And you can quickly graph your line. They'll always be solid for an equal sign. So now I need to take a moment to subtract the 3x from the left to the right, and now I have a second equation to graph. So I'll start at negative 7, and I'll go down 3, right 1, which means I could go backwards, going up 3 and left 1, and now we see our point of intersection. So we have to identify that point where they cross. It's not about shading because it's not inequalities, but that is from the center going left 1 and then down 4. So that is my solution. So now let's try one that has more substitution, elimination. So if you have something that's y equals for one of them, but then the other two are the other equation rather is in standard form, we want to consider using substitution. For example, in this first one, this value, negative 2x plus 9, that is the same as y. So I can say 2x minus 5y equals 15, but it would be better if I could substitute that other equation, negative 2x plus 9, in for where y was sitting, because y, negative 2x plus 9, they are the same thing. So I'm going to distribute to get 10x, distribute to get negative 45, continue looking for like terms, not 20 because it's not multiplying, 2 plus 10, that's 12x, minus 45 equals 15. Add 45 from one side to the other. 12x equals 60. And then we will divide 12 to find out that x has to be 5. Well, for any system, you have to know both x and y. So I'm going to go back into the problem and say, well, y equals negative 2x plus 9. And now I know that x is supposed to be the value of 5. So negative 2 times 5 is negative 10. And if you add 9 to that, you get negative 1. So that is your answer, 5, negative 1. So now we're going to look at one that's in a different format. And I'm going to use some copy pasting to make my job a little easier here. It's like both are in elimination form, meaning they both are in standard form. They both have x and y on the same side. But these are not ready to be added together because nothing eliminates. I need something like negative 15x and positive 15x. And I see that I could change the top equation if I multiplied by something that would change 5 to be negative 15. So if you divide negative 15 by 5, you find out that you need to multiply by negative 3. So negative 3 times 5x. Oh, I am so sorry. I want to multiply by positive 3 because it's already negative 15. I really want to keep this positive 15. 3 times 5, 3 times 9, and 3 times negative 1. So you really want one positive and one negative. Since the second one was already negative, I just want to multiply by positive 3 so that I get positive 15. So I'm going to add these together. You get negative 3y equals negative 3. And if you divide, you find out that y has to be the value of 1. So let's go back into the problem. Let's plug that back in. 5x plus 9y equals negative 1. There we go. And we are trying to plug in the value of 1 in for the y and solve for the x. So 5x minus 9 equals negative 1. That's positive 9, sorry. Let's subtract 9 to the other side, and you get negative 10. And if you divide by 5, you get negative 2. So there's your answer, negative 2, positive 1. So let's take a look at one that has some reading in it, some word problems. It says the function y equals 40x plus 250 is showing the amount of money that Robert has in his savings account after so many weeks, after x weeks. So basically, x represents time that goes by, and what comes out is the money. So x right here, this represents weeks. Week 1, week 2, week 3, how many weeks have you been working? And what will come out is how much money you made. So it says, what is the slope and what does it represent in the scenario? Well, 40, that's in the mx position, or m is 40. So when it says, what is the slope, I'm going to say, well, the m is 40. Well, what does that even mean? Well, let's think about it if you were to make a table of values and say, well, hey, I want to plug in 0. Let's think I didn't work at all. Well, 40 times 0 would be 0, plus 250. Basically, if I have not worked yet, it's like I already had, or Robert already had, $250 in his account. But after 1 week, if you do 40 times 1, 40, plus 250, that would give you $290. So in 1 week, it seems like he's made $40 extra in his account. And if you were to plug in 2, 40 times 2 would be 80, and adding that gives you 330. So that 40 represents $40 each week. That is the amount of money that he is saving each week. He's saving $40 a week. Well, what's that y-intercept? What does this represent here? Well, that's $250. And this represents how much money he had, Robert had, before he started saving. Basically, that was your initial value, and then after that, he's going to start saving 40 a week. But that is his initial amount of money in the account before the time begins to roll and you begin adding money to your account. So it says the school that Catherine goes to is selling tickets for an annual talent show, and on that first day of tickets, they had 4 senior citizens, that's going to be my X, and 3 children's tickets, that's going to be my Y. And it sounds like they sold that for $37. 4x plus 3y equals 37. Well, then they take another scenario and they made a little bit more money. It looks like they made $76, but they sold a different set of values. They sold 12 senior tickets to do that, and they sold 4 a child's tickets to do that. So it says find the price of a senior ticket and the price of a child. We need to find that point of intersection. And so you could use the matrix if you have the calculator, Or I may choose to see that I could multiply this first equation by something that would make negative 12x. For example, negative 3 times 4x would be negative 12x. But I have to do that throughout the entire equation. Let's see, just no mistakes today in the video. Negative 3 times 37, negative 111. So let's now add the two equations together. This first part is elimination. You get negative 5y, and then 76 plus negative 111, that comes out to be negative 35. So if I divide, it seems like for the children's tickets, if you remember I said that y represents how much one child's ticket costs, it looks like that's going to be $7. So I'll leave that for you. See if you can tell me if y is 7, what does that make x? If you're supposed to plug it in and get 37 or 76. So try that one independently. Finding slope. We have y2 minus y1 over x2 minus x1. So this is going to be my formula for the rate of change, and that's m equals. So I want to plug it into the formula. I have 8 minus 0, and then I have negative 4 minus 20. Jumping back in, 8 minus 0, 8. Negative 4 minus 20, negative 24. So that ends up giving us negative 1/3 for the slope. So remember that they're asking about the slope, so just changing this into y equals mx plus b doesn't really answer the question. You got to tell me the slope from the equation. So let's solve it. For y, negative 5y equals negative 2x plus 15. And then I'm going to divide by negative 5. And look for those signs to kind of cancel out. This would be positive 2/5 minus 3. So many students just circle that and move on, but I didn't tell the slope. I just told what it was in slope-intercept form. And so hopefully you're identifying 2/5. That value represents that rate of change. So if you're in one of my afternoon classes, I may have given you a second half. So let's jump into a few of the inequality questions. Starting at 5, I want to go up 1 and over 2 to get my slope going. And then always make sure you ask yourself, should this be dashed or solid? Solid line or equal? Now I have to shade based on the word that is y greater than. So I want to shade above the line. Let's now graph that second one. This is a very special line. This should be more of a vertical line if you're talking about only x in the equation or the inequality. So I want to go find where x is 2. And then this one is a dashed line because I don't want any values to be equal to 2, only values greater than 2. So if I shade greater than 2, that would be to the right of this line, but the solution is really just any point in this upper part. Okay? But that can be a little harder if you have to solve for y. So I want to take that first one. Let's subtract 4x to the other side. That is the first step, to minus 4x from one side to the other. And then dividing by 3 will get me y by itself. And now I can graph. So hopefully that's something that we're working on improving. Starting at positive 3, I'm going down 4, right 3, down 4, right 3, as many times as I can. Okay. And then I want that to be a solid line. So you try the second one, see if you can shade that correctly to find that point of that region that kind of intersects itself. And then I gave you some other ideas. Just tell me, is that point on the line, yes or no? Not in the line, is it in the shaded region? Okay. Good luck, and we'll see you tomorrow.